Unit 5.5, determine absolute extrema from candidates. The critical points give us possibilities of finding a max or a min. The ends of the interval, or the endpoints, give us other possibilities of finding a max or a min. So I'm going to draw a graph or a function. I'm just going to make something up. Let's do that. So these are endpoints. I'm going to label them EP for endpoints. And then critical points are like, this would be a critical point, this would be a critical point, this would be a critical point, and this would be a critical point. Candidates for absolute extrema on an interval are 1, the critical points, or the endpoints. So that's why I just labeled them. Find the absolute maximum value and the absolute minimum value of the function f of x equals x cubed minus 3x squared plus 1 on the interval -½ to 4. Remember to show that you checked all the candidates. First, you want to find the derivative of f of x. So f prime of x equals 3x squared minus 6x. Now we factor 3x x minus 2, and then we can find that the zeros are x equals 0 and 2. So those are the critical points, and then these are the two. So these are the two endpoints. So the candidates are -½ f of 0, f of 2, and f of 4. Now you want to plug these back into the equation and find, well, this is 1.25, this is 1, this is -3, this is 17. So we can see that the absolute max is 17. Value is 17. The absolute min value is the lowest number, so -3. Looking at the graph of f prime, we can identify relative extrema at the x-intercepts. Can you find the x-coordinate of the absolute maximum and the absolute minimum? So, first we know that anything above 0 is increasing, anything below 0 is decreasing. So first, let's look at the max. Okay, the two candidates are x equals 1 and x equals 4. Because when you have a maximum, it begins to decrease as it's moving away from the maximum, right? So it's decreasing right here, and right here it rises, so at this point it's going to decrease. Now, which one is the absolute max? Well, we can see that right here it decreases a lot more than it does right here. So that means that the absolute max was x equals 1. Absolute minimum, our two candidates are x equals -3 and x equals +3. Because to have a minimum, it has to be positive leading up to it, or not, has to go positive leaving away from it. So right here is going positive away, and right here it's going from negative, so it has to be increasing, like leaving it. So right here is increasing all the way, leaving this point, and right here it's increasing just a little bit. But we can see that it increases a lot more here than it does here. So that we know that the min is x equals -3, absolute min.